What if we're completely alone in a universe with over 100 billion galaxies? Every night, the stars above whisper the same question: where is everybody? For every sun we see, there are countless planets that could host life. Statistically, someone should be out there. Civilizations older, wiser, far more advanced than us. And yet, silence. This is the Fermi Paradox, the haunting mystery that keeps astronomers, philosophers, and dreamers awake at night. If the cosmos is teeming with life, why haven't we heard a single voice? Stay till the end, because the answers we've uncovered may change everything we thought we knew about existence itself. And if you love exploring the greatest mysteries of space and time, subscribe. For decades, humanity has looked up at the night sky with wonder, imagining that somewhere out there among the billions of stars in our galaxy, life must exist. The universe is vast, incomprehensibly immense, containing more stars than grains of sand on all the beaches of Earth combined. And yet silent. No messages, no signals, no contact. We have searched the heavens with radio telescopes, scanned the skies for patterns, intercepted cosmic whispers, and still we hear nothing. This silence is unnerving. It's more than the absence of evidence. It's a question that keeps scientists awake at night. If the cosmos is so large and life is statistically inevitable, why haven't we encountered anyone? This is the Fermi Paradox, a puzzle that challenges everything we think we know about life in the universe. Today we will explore the depths of this mystery, the theories, the calculations, and the haunting possibilities in a journey that may forever change the way you see the stars. The origins of the paradox. In 1950, physicist Enrico Fermi posed a question during a casual lunchtime conversation: where is everybody? His curiosity was simple yet profound. By that time, the knowledge of the Milky Way and its billions of stars was growing rapidly. If life is common and civilizations advance technologically, the galaxy should already be teeming with them, or at least we should see evidence of their existence. Fermi's offhand remark became a central question that challenges modern astronomy, astrobiology, and even philosophy. The paradox is rooted in a few assumptions. The universe is old, there are billions of potentially habitable planets, and life is not unique to Earth. Civilizations capable of interstellar travel could have colonized the galaxy multiple times over, and yet we observe only silence. This simple question has spawned countless debates, papers, and hypotheses, each attempting to explain the staggering emptiness that surrounds us. The scale of the universe. To grasp the paradox, we first need to understand the scale of the universe. Our Milky Way galaxy contains roughly 200 to 400 billion stars, and recent discoveries suggest that most stars host planetary systems. Some of these planets orbit within the habitable zone, the so-called Goldilocks zone, where conditions might allow liquid water to exist, a key ingredient for life as we know it. Multiply this across trillions of galaxies, each containing billions of stars, and the numbers become mind-boggling. Statistically, it seems impossible for Earth to be unique. With so many planets, the probability that at least some have developed intelligent life appears almost certain. Even if advanced civilizations are rare, there should be at least a few detectable signs: energy emissions, megastructures, or signals. Yet the cosmos remains eerily quiet. The Drake equation, estimating the odds. One of the first attempts to quantify the likelihood of intelligent life in our galaxy came from Frank Drake in 1961. The Drake equation is a probabilistic formula that multiplies several factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per system, the likelihood of life developing, the fraction evolving intelligence, the chance of detectable technological civilizations, and their longevity. Each variable carries uncertainty. Some are based on observation, like the prevalence of planets. Others, like the likelihood of life arising, remain largely speculative. Depending on the assumptions, the equation can produce numbers ranging from almost zero to millions of civilizations in our galaxy alone. Yet, no matter how optimistic the calculation, the result confronts the same reality: possible explanations for the silence. Over the decades, scientists have proposed dozens of theories to explain the Fermi Paradox. Some suggest we are simply early. Humanity might be one of the first intelligent civilizations in the galaxy. Others propose that advanced civilizations self-destruct before achieving interstellar travel, destroyed by war, environmental collapse, or artificial intelligence. The Great Filter hypothesis is particularly chilling. It posits that somewhere along the evolutionary path, life must overcome extreme hurdles to reach advanced intelligence. This filter could lie in our past, meaning humanity has already survived the hardest challenge, or it could lie ahead, suggesting a grim future where most civilizations fail before spreading across the stars. The zoo hypothesis. Another possibility is that advanced extraterrestrials are deliberately avoiding us, observing Earth like a protected exhibit in a cosmic zoo. Perhaps they have agreed not to interfere until we reach a certain level of maturity or technological capability. This raises unsettling questions about our autonomy and the true nature of intelligence in the universe. Are we really alone, or are we simply too early, too primitive, to be acknowledged? Interstellar distances and the communication barrier. Even if other civilizations exist, vast distances make interaction extraordinarily difficult. The nearest potentially habitable exoplanets are light years away. Sending and receiving signals could take decades, centuries, or millennia. Furthermore, technological civilizations might use communication methods beyond our current understanding, leaving us deaf to their presence. The universe may be buzzing with activity, but humanity may simply lack the ability to perceive it. Technosignatures and silent evidence. Recent research has shifted from searching for radio signals alone to seeking technosignatures, observable signs of advanced civilizations. This includes megastructures, industrial pollutants, or unusual stellar phenomena. Yet, despite the sophistication of our telescopes and the scope of our surveys, no definitive evidence has appeared. Each non-detection adds weight to the paradox, reinforcing the unsettling reality: the galaxy may be far emptier than we hoped. The possibility of parallel civilizations. Some scientists argue that multiple intelligent civilizations could exist simultaneously, but remain isolated. Different developmental timelines, planetary isolation, and natural disasters could prevent contact. Civilizations might arise and vanish before ever overlapping with another. In this scenario, the silence is not intentional or sinister. It's a statistical inevitability. Cosmic catastrophes and life's fragility. Earth itself demonstrates the fragility of life. Mass extinctions, asteroid impacts, supervolcanoes, and climate shifts have repeatedly threatened complex life. It's possible that intelligent life is rare because the universe is hostile. Even planets with ideal conditions may fail to sustain life long enough for civilizations to emerge and explore the stars. Philosophical implications. The Fermi Paradox isn't just a scientific puzzle. It's a mirror reflecting humanity's place in the cosmos. If we are alone, life on Earth becomes extraordinarily precious, highlighting our responsibility to preserve it. If we are not alone, the silence becomes a warning, a lesson in humility about the challenges civilizations face. Every theory forces us to confront the enormity of the universe and the tenuousness of our own existence. The future of search advances in technology may eventually solve the paradox. Next-generation telescopes, deep space probes, and artificial intelligence-driven analysis could detect subtle signs of life far beyond our solar system. Exoplanet surveys are identifying more habitable worlds every year, increasing the chances of discovery. But the question remains, when we finally find another civilization, will they be friendly, indifferent, or extinct? The silence that speaks. The Fermi Paradox reminds us of the mysteries that still lie beyond our understanding. Every star we observe may hide civilizations just beyond our reach. Every moment of silence may carry its own story, waiting for the day we finally listen closely enough to hear it. As humanity continues to reach for the stars, the question endures: where is everybody? And perhaps more importantly, what will we do when we finally discover the answer? Advanced civilizations and the Great Filter. One of the most compelling explanations for the Fermi Paradox is the concept of the Great Filter, a series of improbable steps that life must navigate to reach advanced intelligence. Perhaps simple life is common, but complex, self-aware civilizations are exceedingly rare. The filter could lie in the emergence of multicellular life, the development of technology, or the ability to avoid self-destruction. Some theorists worry that the Great Filter lies ahead of us, meaning that while we've survived the early hurdles, the most difficult challenge, sustaining a civilization long enough to reach the stars, may still be looming. This grim hypothesis forces humanity to reflect on our trajectory. Our technological prowess has skyrocketed, but so has our ability to destroy ourselves. Nuclear weapons, climate change, pandemics, and artificial intelligence represent potential filters that could prevent long-term survival. In essence, the silence in the galaxy could be a warning. Civilizations rarely make it past their most dangerous stage. The rare Earth hypothesis. While the universe is vast, Earth might be a truly unique cradle of life. The rare Earth hypothesis suggests that while simple microbial life might exist elsewhere, Planets capable of supporting complex life are extraordinarily uncommon. Factors like a stable star, a protective magnetic field, the presence of a large moon, plate tectonics, and a stable climate over billions of years may be exceedingly rare. In this view, intelligent life might be almost non-existent beyond our planet, explaining why the galaxy seems silent. Self-imposed silence. The dark forest theory. Some of the most chilling explanations involve the idea that advanced civilizations intentionally avoid broadcasting their existence. The dark forest theory posits that in a universe filled with potentially hostile civilizations, staying quiet is the only way to survive. Broadcasting one's presence could attract predators. From this perspective, the silence isn't absence, it's fear. Every civilization may be hiding, waiting, watching, unwilling to take the risk of making contact. Humanity's curiosity might be dangerous if others are already out there, listening. Technological limitations and detection challenges. Even if civilizations are common, we may lack the tools to detect them. They could use communication methods far beyond radio waves, quantum signals, neutrino beams, or technologies we haven't yet conceived. Our current SETI programs, though sophisticated, are limited to certain frequencies and types of emissions. The universe may be alive with signals we cannot perceive, meaning the silence is not real, but a limitation of our senses. Interstellar travel. Barriers and bottlenecks. Another reason we haven't encountered extraterrestrials could be the sheer difficulty of interstellar travel. Even with advanced propulsion systems, distances between stars are enormous. A civilization capable of reaching the nearest star systems would need technology far beyond ours. And even then, colonization might take millennia. Civilizations may simply be unable or unwilling to spread, choosing to remain within their own star systems or virtual environments. Time and civilization. Lifespan time adds another layer to the paradox. Civilizations may rise and fall in cosmic blink-of-an-eye timescales. While the Milky Way is billions of years old, the lifespan of technological civilizations could be mere thousands of years. The probability of two civilizations overlapping in time could be extraordinarily low. This temporal isolation could explain why we see no evidence of others. We exist in a brief window of observation amidst a galaxy of long-extinct civilizations, signs we might be missing. Despite the apparent silence, there may be subtle signs of extraterrestrial intelligence that we haven't recognized. Unexplained stellar phenomena, irregular light patterns, or even unexplained energy emissions could be technosignatures. Some researchers argue that historical anomalies, such as certain pulsar signals or mysterious cosmic bursts, deserve deeper scrutiny. It's possible the universe has been trying to tell us something, and we simply haven't understood the message yet. Philosophical reflections. The Fermi Paradox forces humanity to confront existential questions. If we are alone, the responsibility to preserve life on Earth becomes immense. If intelligent life is rare, the beauty and fragility of our planet are amplified. Conversely, if other civilizations exist but remain silent, it may suggest wisdom or caution in survival. Lessons humanity could learn before it's too late. Every theory challenges us to reflect not just on the cosmos, but on our own civilization's values, decisions, and future. Future prospects. Will we ever know? Advances in astronomy, astrophysics, and AI might eventually provide answers. Instruments capable of detecting biosignatures, such as unusual atmospheric compositions on distant planets, could reveal life long before interstellar contact is possible. Projects like the James Webb Space Telescope, next-generation radio arrays, and deep space exploration missions are slowly expanding our window to the cosmos. The first discovery of extraterrestrial life, even microbial, would be revolutionary, reshaping science, philosophy, and human identity, humanity's role in the cosmic silence. Regardless of the outcome, the Fermi Paradox teaches one enduring lesson. The universe is immense, indifferent, and full of mystery. Humanity's search is not just about finding others, it's about understanding ourselves. Our choices, our survival, and our legacy may determine whether we eventually break the silence or become just another brief whisper lost in the cosmic night. Outro. Listening to the stars. The universe remains vast, silent, and tantalizingly full of possibility. Every star may hide a story, Every signal may be waiting to be understood. We may not know the answer to Fermi's haunting question today, tomorrow, or even in 1,000 years. But the search itself defines us, a species curious, courageous, and determined to find its place among the stars. If this journey through the cosmic mystery intrigued you, subscribe now and stay with us. More secrets of the universe await. And together we'll continue listening to the silence, uncovering the stories hidden among the stars.